On May 20th, 2026, in a quiet blog post almost nobody read, OpenAI announced something mathematicians had been waiting 80 years for. The post opened with this: for the first time, an AI has autonomously solved a prominent open problem central to a subfield of mathematics. The problem was an 80-year-old conjecture by Paul Erdős. The formal proof was 19 pages long. The chain of reasoning behind it ran to 125 pages. And here's the part that should stop you. The man who verified it, Tim Gowers, is a Fields Medalist who has spent years publicly questioning whether AI can do real mathematics. He read the proof, and then he wrote this: if a human had written this paper and submitted it to the Annals of Mathematics, and I had been asked for a quick opinion, I would have recommended acceptance without any hesitation. 2 days later, OpenAI filed for IPO. The math result got buried, so did this. Last fall, an OpenAI vice president claimed GPT-5 had cracked 10 unsolved Erdos problems. The mathematician who runs the Erdos problems database, Thomas Bloom, debunked it publicly. He called it a dramatic misrepresentation. That same Thomas Bloom is now a co-author on this paper. The harshest critic became the verifier. This is the story of how that happened. And why? 6 months after Terence Tao let AI help write a math paper, and AI just wrote one on its own. 1946, Paul Erdős was already the most prolific mathematician of the 20th century. He posed a simple question. Imagine you're arranging dots on a piece of paper. Your goal? Pack in as many 1-inch apart pairs as possible. Every 2 dots that are exactly 1 inch apart count as 1 pair. What arrangement of dots gives you the most pairs? Erdos proposed an answer that same year. Use a grid. Pick the spacing carefully so that lots of grid points land exactly 1 inch from each other. Count up the pairs. He believed this simple grid was essentially the best possible arrangement. No clever trick could meaningfully beat it. For 80 years, nobody beat the grid. Mathematicians tried both directions, looking for a better arrangement and trying to prove no better arrangement could exist. They never closed the gap. Erdos himself offered $500 for proof. The prize was never claimed. Then, on May 20th, 2026, the grid finally lost, by a method no human had tried. If you've read about AI in the last 3 years, you've read his work, even if you don't know his name. His name is Sébastien Bubeck, French mathematician, 41 years old. PhD from Lille in 2010 under Remy Munoz. 3 years at Princeton, 10 years at Microsoft Research, where he eventually led the Machine Learning Foundations Group. In March 2023, Bubeck and 13 colleagues released a paper on arXiv. The title was Sparks of Artificial General Intelligence, 155 pages. The thesis, GPT-4, was the first system that showed signs of general intelligence, not just narrow capability. That paper ignited the modern AGI debate. Gary Marcus called it a press release masquerading as science. Other researchers said it captured what they were seeing in their own labs. The Sparks paper was never peer-reviewed, but it set the frame. 18 months later, on October 14th, 2024, Bubeck left Microsoft. He crossed to OpenAI. His public mission, work on the company's goal of reaching AGI. His private thesis was sharper. Math is the cleanest test for AI doing real science, because in math, you cannot fake a result. A hallucinated proof falls apart the moment a real mathematician reads it. The proof either checks out or it doesn't. The dress rehearsal came August 2025. Bubeck posted on X. He'd handed GPT-5 Pro a math problem from a published research paper. The kind where the existing answer was the best anyone had found. The model thought for 17 minutes and produced a better one. Bubeck checked the work. It was correct. That was August. The big one came 9 months later. And what it did was something the field had been telling itself was at least 5 years away. OpenAI gave the model one prompt, the bear problem. Erdős's 80-year-old conjecture, nothing else, no hints, no engineered guidance, no specialized math training. The model is what OpenAI calls an internal experimental reasoning model. They have not given it a name. It is not GPT-5, not O3, not anything publicly released. Just a general-purpose reasoner. It ran. For a long time, OpenAI has not disclosed how long. Days, possibly weeks. The output was a chain of reasoning 125 pages long. What it found was a new arrangement, a pattern nobody had thought to try. This arrangement isn't a grid, it's something stranger. The model built it using a 19th century branch of math called algebraic number theory. It constructed a pattern in a higher dimensional space, then folded it back down onto the flat page. The kind of move a human mathematician might spend a decade learning before thinking to try it. How much better is this new arrangement than the grid? Just a hair, microscopic, smaller than anything you can physically measure, but that's the whole story. Erdos had predicted no arrangement could meaningfully beat the grid, not by anything measurable. He was wrong. The AI's arrangement beats the grid by a permanent, tiny, unkillable margin. Microscopic, but not zero. And not zero is everything. Because Erdos had said zero, Erdős's conjecture was wrong. Gil Kalai, one of the world's leading combinatorialists, wrote on his blog that this is a scientific landmark whose importance goes beyond combinatorics and beyond mathematics. OpenAI did not publish this alone. They sent the proof to 9 independent mathematicians across Princeton, Toronto, Cambridge, Manchester, Harvard, and Academia Sinica. Tim Gowers was one. So was Thomas Bloom, the same critic from October. 2 days to verify. They could not find a flaw. A few of them pushed back honestly. Melanie Matchett Wood at Harvard wrote that the same 9 mathematicians, given the same problem and the same month, would have found a counterexample themselves. And Bubeck himself called the result executing like an amazing mathematician. Not inventing something fundamentally new, just executing brilliantly, on its own. That distinction is the story. 1976, University of Illinois. Kenneth Appel and Wolfgang Haken announced the first proof of the 4-color theorem. Every map can be colored with 4 colors, so no neighbors match. The proof required more than 1,000 hours of mainframe time on an IBM 360 with 64 kilobytes of memory. It checked 1,834 configurations by brute force. Half the mathematical community refused to call it a proof. The geometer H.S.M. Coxeter wrote that it is very unlikely anyone can break this down into an ordinary proof. The philosopher Thomas T. Mochko coined a term for it, non-surveyable, a proof too long for any human to read end to end. The debate lasted 30 years. 2005, Georges Gontier at Microsoft Research Cambridge formalizes the proof in a system called COKE, every step verified by software. The debate ends. 2024, Alpha Proof scores silver at the International Mathematical Olympiad. Artificial intelligence solves problems humans set, not new problems. Olympiad problems, but still. The frontier moved. November 2025. Terence Tao publishes a paper that uses 3 AI systems, Alpha Evolve, DeepThink, and Alpha Proof, to explore 67 open math problems. The paper has 4 human authors. The AI is the tool, the collaborator. May 20th, 2026. The OpenAI model produces a proof on its own, no human co-author. The byline reads simply, OpenAI. 9 mathematicians signed the verification, 50 years. From a computer that checked 1,834 cases to an AI that found one idea no human had. 5 eras, 5 roles, bookkeeper, verifier, apprentice, collaborator, discoverer. The thesis sentence is this. In 6 months, AI has crossed from co-author to solo researcher. And the same month it happened, the man who taught a machine to beat humans at the game of Go without ever showing it a human game raised $1.1 billion to do the same for everything else. David Silver, 13 years at DeepMind, lead researcher on AlphaGo, AlphaZero, AlphaStar. He left this January. In April, he announced his new company. The name is Ineffable Intelligence. The thesis: build a system that discovers all knowledge directly through its own experience. No pre-training, no imitation. The funding round was the largest seed round in European history. Sequoia and Lightspeed led. Nvidia, Google, and the UK sovereign AI fund all participated. Silver and his collaborators wrote in 2025 that AI is at the cusp of a new period in which experience will become the dominant medium of improvement and ultimately dwarf the scale of human data used in today's systems. Look at what arrived in 6 months. Tao using AI to explore 67 open problems. Bubeck's model autonomously cracking one of them. Silver raising $1 billion to scale the no human data idea past go to everything else. For 80 years, no human cracked the Erdos unit distance conjecture. Then, we built something that did. Tim Gowers said it best. We have still probably entered an era where it will become very difficult for humans to compete with AI at solving mathematical problems. The question is no longer whether AI can do original research. It's what it discovers next, and whether the rest of us are ready when it does.